Everyone should turn on your cameras. Assalamu alaikum. Hi guys. Good evening. My name is my
Islam.
name my name is Azizul Hassan. Basically, I'm a solar design engineer and also I'm providing uh, the freelance services in the solar designing field and also the trainings. And also, I'm doing a job as a senior design engineer in international company. So first of all, I want everyone should introduce itself by shortly. Uh, Country name, profession, and the name one by one. Mr. Ahmed.
Yes, hi. Assalamu alaikum. My name is Ahmed Fath Rahman. I am solar design engineering. I am from Sudan. I work with UNDP here in Sudan for solar.
Okay, thank you, thank you. Mr. Alex.
Good evening, all.
Good evening.
I'm Alex. Malik Tanwi from Kenya, design
Okay.
engineer.
Okay.
Yes.
Mr. Samuel. Rahmatullah. Mr. Rahmatullah.
Good evening. I hope everyone doing well. I am Rahmatullah and I'm a solar engineer from Afghanistan.
Thank you. Yes, Mr.
Hi.
Samuel.
Welcome.
Sorry, I didn't know I was nominated. My name is Samuel Basi. I'm from Nigeria. I'm a solar system design engineer. I work with the Paras Energy.
Okay, thank you. Mr. Kazi.
Assalamu alaikum. I am Kazi
Well,
Masum. We are working in Bangladesh and I'm in the solar system designer also. Our company name is Medzi Energy Solution Limited.
okay, thank you. Mr. LA.
Hello, good evening. My name is El Namanya from Uganda. I'm an electrical engineer. Thank you.
Okay, thank you. Mr. Nobi.
Good evening. I'm MD Mahfuzun Nabi Mahim. I'm from Bangladesh. I'm also working as a renewable engineer, and currently I'm working for Lafarge in Bangladesh. Thank you.
Thank you. Mr. Simon.
Yeah, good.
Yes, Mr. Peter. Small intro. Mr. Narendra. Welcome again.
How are you, sir?
How are you?
I'm perfect, sir.
Thank you.
What are the course
So,
contents, sir, in this?
yes, sir.
Is this only design of rooftop or any, just we have taken the previous course similar to that?
No. Basically, it is a free session and it will be for the roof mount 100 kilowatt design.
Like the SketchUp and PVsyst?
Yes, the intro. Like basically, you know that in one class we just explain the.
Yeah, I understood. The free
Oh,
class series
yes,
session
yes,
for which course I'm asking, sir?
yes.
Fine, fine, sir.
Okay, thank you. Okay, guys, I think we will start our lectures. Most of the people which are interested in that free session have joined that class, and I am very hopeful that when you will complete the session, most of the things I will explain all of you will be clear to all of you. And if you have any question, I will ask randomly in the sessions. Will ask the question from all of you. So kindly be active, be participant, and will try to answer me when I will ask the questions in between of the sessions. So basically, this class is uh, pa- uh, for the 2 hours. In first hour, I will explain the different topology and other things, the technical things. But uh, after 1 hour, in the second part of that sessions, uh, we will have a like a 10 to 15-minute breaks in between that session because it's too much long session, and everyone should need some break. And after when we will come back in that session, we will do the 100 kilowatt solar system design properly on the SketchUp. Then we will make a PVC simulation report. Then we will convert that SketchUp into the AutoCAD file, and we will compile in one AutoCAD file. So just uh, for that, I'm just starting my lecture and sharing my screen. Uh, s- okay, just sharing my screen. So basically, I have just give you the short overview of myself. My name is Azizul Hassan, and I will explain that I'm a solar design engineer, like a 7 year of experience. I'm providing the different online services to the different companies, like in the USA, in the UK, in the South Africa regions, and other things, different countries. Germany, I have one client. So in parallel, I am providing the training sessions to the different students which needs the training. So in parallel, also I am doing a proper job as a senior solar design engineer in international company, which is basically based in the South Africa region, and we are doing from the Pakistan regions online the solar system design for the 100 megawatt, 200 megawatts, 300 megawatt systems. So it is a short intro of myself, and then I have just one small company registered in Pakistan, kWp Energy Solution, on which basis I am providing the certificate to the everyone who have attended the sessions and the other different trainings. So that is my company and my self intro. Then we move on to our this session introduction. Basically, this uh, uh, the objective of that webinar is to give the short and precise introduction and to the the process everyone to get familiar with the layout making on the for the rooftop systems on the SketchUp, on the AutoCAD, and then we make the simulation report on that basis. So, and also I will explain the basic fundamental of the solar system, is in importance in the its type systems, and the the other basic data we require for the solar system designing, and the key importance, and then the which mistake we have done in our solar system designing. On that basis, I will explain the overall overview of that things, and then we will analyze how we will use the software like the SketchUp, PVsyst, AutoCAD, and their commands and other things, but in the short intro and short period of the time. So, first of all, why solar energy why solar energy required? Basically, the solar system is the energy we get from the suns, and convert these sun rays in. Kindly, kindly mute yourself. Kindly mute yourself. Kindly. Then basically, my voice is clear, guys.
Yes, yes.
Yes, clear.
Okay, thank you. Thank you.
यस हसन
So
भाई आवाज क्लियर है आपकी यस क्लियर आप
okay, that's great. So basically, the sun lights which are we getting in the abundant forms will convert these rays into the form of the electrical energy, in the form of the energy. And on that energy, we will run our different appliances like so. So convert these solar rays to the form of the electrical energy. Some medium are required, like the solar panels, solar PV modules. There, when the solar radiance strike on that PV modules, they will convert into the DC energy. Photons will convert into the DC energy, and then DC energy travel to the inverters, and then they through the wires, and they will convert these the DC energy into the form of the AC energy. And basically the most of the our appliances which are uh, alternative current runnings. So that is why we require the inverters for that reason. So why they are in the demand of the solars in that recent era? Because it has the one time cost, like when you are installing the solar system on your rooftops or in your factories and other things. One time you are paying to the companies which they are basically installing the solar systems, and after that you will get the energy like for the 20 years, 25 year and 30 years different. So we have, after that we have just small amount of the O&M cost. But in parallel, if we do the hydro power plants and the other steam power plants, other things, they have the capital cost is lower than that, like in comparison to the solars. But their operation and maintenance costs and their energy uh, numbers cost, energy number cost, per energy number cost will be higher than the solar system. So that is why basically they are in the renewables, and they are the get from the in the free from the suns. So that is why they are in the demand position in the recent era and coming years. And the benefits I have already explained, that they are the cost saving because they have only one uh, capital cost, and the other thing is that they have just small amount of the operation and maintenance cost. Like after 10 years, 15 years, 12 years, we have some issue in the inverter and we have to replace them. They have the cost. Like the other cost is the cleaning of the panels. This is the cost. And like the small cables will create an issue in the times years. So that is the cost, small amount of cost. Eco-friendly means that uh, it is not a complex system. It is not a complex system like the steam power plant, the hydrogen power plant, like the hydel power plants, other things, other part of the energy. They are basically, we have just installed the solar panels, and we have to install the inverter and then transformer, and then it is the power. But like in the parallel, we will discuss like the stream power plant. We have to install the boiler. Then we need we need the boilers and the then we need the water in abundant form. Then they will convert it to the steam form. Then we need the proper channels through that, and we have the turbine system and other things. So that is very easy and eco-friendly. Energy security. Energy security means that when the sun is available in that time, like the daytime, it will like energy is available. But it has some like drawbacks are also available in solar power plant. Like the solar power plant has the issue is that we just run our appliances in daytime when the sun is available. But for the night time, we have to like the backup systems. We have to use the the country WAPDA systems, electricity. So that is the main reason, the drawback of that solar system. We have, if we have to use in the night time, we have to add the parallel system like the backup system, like in the form of the BESS systems, in the form of the electricity from the grid, other things. That is one drawback of that. And the other drawback is that the capital cost is much larger. A poor people will not bear this cost in the capital cost, because we have to pay first time higher number of higher amount to install the solar power plant. Solar energy is sustainable and does not deplete natural resources because it is the sun. It is available to the when the whole world is demolished. At that time, the sun is available. Then it should be converted that sun's rays into the form of the energy. Save energy cost by generating own power. Like we are in that position, we have installed the solar power plant on our rooftop, and we are generating our own electricity. And in the form of the net metering systems, we are providing to the grid, the WAPDA systems, electrical companies. So they are basically saving the cost and also uh, saving the bills and other things. Less design and utility companies. Then when we have installed the solar power plant on the roof systems, our reliance on the grid companies will like decreased. We have to take the power from the grid in the night time. But for the daytime, we have our own electricity. Then we talk about the types of the solar systems. We have basically three types of solar systems. One is on-grid, off-grid, and hybrid. Uh, Kindly mute yourself, Andy. So we have three type of solar systems. One is on-grid system, off-grid system, and other one is the hybrid system. I will explain one by one in parallel. First is the on-grid system, grid-tied system flow chart. You can see that our solar systems, then the DC protection, these to the solar inverter, and then AC protection. AC protection show the distribution cabinet or power supply equipments. So means that we have only solar system, inverter, and then grid. We have just two source of the energy available in our power plant, in our home. No other options there. So is, is unmuted, please mute yourself. Okay, so we have just two source of energy available. One is the solar, and the other one is the electricity from the grid. The reason and the one drawback of that on-grid system is that when your grid is off, your solar system is in parallel will be off. Why? Anyone know the reason why on-grid system will be off when your solar grid will be off? Why? Any reason? Anyone from you?
It needs reference voltage for the solar generation.
Reference voltage. Any other reason? Most of the
Can you
people
ask
are
again?
from.
Your question again, please.
Why?
Your question again.
I'm asking about that. When the grid is off, the on-grid system will be in parallel, will be off. They are not generating the energy. Energy will be generated, but your inverter will be off. Why? Any reason? Because most of the people from
Okay.
the. Yes.
Okay, yeah. When you have a grid connected system using a grid following inverter, we have a grid following and grid forming. So for the grid following inverter, it requires a reference voltage and frequency from the grid. And in order to also to safeguard this maybe personnel working on the grid, because the grid could be off due to maintenance, it could be off due to faults. And if the inverter keep sending power to the grid, it's going to be dangerous, it's going to harm whosoever is on the line for maintenance. So the system is going to go off, is designed to go off whenever it says that the voltage or frequency from the grid is off. It's I think by IEC standard between two seconds. When it notices that there is no reference voltage from the grid, it trip off.
Okay, that's great. That's great, Mr. Simon. Thank you very much
I
for
think
explaining. Yes.
I think due to anti-islanding protection, that's why the inverter is also shut when grid is shut.
Yes. That's great. Okay, thank you. Thank you very much for explaining and participating in the class. Okay. And the other part is the off-grid and the standalone systems. Basically, the standalone is only the PV charge controller battery system available. No grid is available. With just the PV array sent to the charge controller are the off-grid inverters, and that off-grid inverter will charge the batteries, and the DC load are the AC loads through the inverters. But this charge controller and the inverter now mostly in the one form of the off-grid are standalone inverters. They are built in within the inverter, the charge controller. So when there is no grid is available, the off-grid basically used for the the remote area where no grid is available, and we have to uh, run our appliances. So for that, we will use or we will prefer the off-grid and the standalone systems. And the third one is the basically the combo of that two parts, the on-grid system and off-grid system. It is basically the combo of that both systems, in which we have the hybrid inverters. They basically the topology to work on the basis of the standalone systems and also on the basis of the uh, on-grid system. They will reverse. They have the capability to send back the energy to the grid, and also uh, they have the capability so they have the capability to uh, send back the energy to the grid, and also they have the ability to charge the battery. When there is no grid is available, the hybrid system will not turn off, because they will run on the battery system, but they will not send back the energy to the grid when the grid is off. They will not. So this is the hybrid system, the off-grid, and I have just given the overview of that. But if someone like from this class and from your client will prefer and has a backup system, want the backup system, hybrid system is preferable. But they have some maintenance issues in uh, what is the issue? Features, Rahmatullah Yusuf say again and again. Uh, so now we move on to the next system. Then we have the tools overview. We have the tool overview in AutoCAD, SketchUp, PVsyst, and other software will be used in the solar industry, like the SimCap for the thermal assessment of the cables. We uh, for the thermal assessment of the cable, other software will be used, like the T-tabs, the Power Factory. Most of the software will be used, but for the layout making, for the shading analysis, for the simulation of the energy report, uh, these three software will be used. AutoCAD will be mostly used for the 2D drawings. The 3D drawings most of the time we can make, but it is very difficult to make the 3D drawings in the AutoCAD. Uh, but we can make that. But for the official submission of the drawings in the form of the 2D, the side views, and the typical installation of the drawings, we will use the AutoCAD software. It is correct. PV layout, easy scaling, measurement, official documentation systems, we will use the AutoCAD software. But if we have to like uh, do the thermal assessments, if we have to use the the 3D visualization, the shading analysis, and visual side modeling, better client understanding, we are using the SketchUp software. Why people are most of the time joining and leaving and joining. So it will be used to analyze the 3D shading analysis, we can see that how much the shadow is present in the time of the peak hours of the solar systems, and the time zone in which we are gaining the global GHI, global horizontal irradiance, in from higher than the 100 watt per meter square, and in the night time it will be less than 100 watt per meter square. We can analyze that how much shadow is impacted through the any obstacle available in our solar power plant, like the MV station's height, the poles height, like the lightning pole, the light pole, the inverter canopies and other things in like in the form of the ground mounted system. On the rooftop system, we have different rooftops and other mumties available on that rooftops. So we can analyze that how much shadow is impacted on our solar systems. uh, it will like have more visualizations, because when some client is very uh, not a technical person, and we show them the 2D drawings, they will not analyze properly. They don't see that what is this, just and but when you show them the 3D view of that solar system, how uh, so when the person is not a technical one, when you show them the proper the modeling on the SketchUp, show them what is your house looking and how the solar system is looking on that, it will mostly convinced. That is why it is very important for the residential softwares, residential and commercials usage. And also, I have seen that most of like uh, the international companies will use that SketchUp software to visualize the shadings and other things, the road spacings and other things on the ground mount systems. We are where I am working as an international company. We are using the SketchUp for join again. Why they are reason? And then we move on to the third one. Third one is the PVC simulations. Basically, it will use to give the report of the energy numbers, the performance. On the basis of the losses, we will analyze in our proper calculations. Like we have to give them join again. Energy numbers on the basis of the losses, we will give them to our solar system in the simulation of that PVC software. Like I will explain. When we are doing our cable sizing, we will calculate our voltage drop and power losses. We will give them that losses in the form of the DC ohmic losses and AC ohmic losses to the simulations. This will this will give them the simulation report, which give them the energy number, the performance. On that basis, we will convince our client that we will convince our client that it is the systems, how much is the DC capacity, how much is the AC capacity. These are the losses. I'm assumption calculating. Some losses are assumption based and some are the calculation based. And on that basis, we are simulating our solar systems report, and this will give them the energy number for the first year. Then from the second to the 30 years, how much is the energy number they will give them, how much is the performance ratio of that. So this PVsyst software is very important. What is very important for the energy simulations. When I will do the simulation report, simulation in our next part of that lecture, I will tell them the losses and other things. And then when we are designing our solar system, we need some input, like from the client, from the survey data, and other things. Rahmatullah, what is the reason why are you joining and losing again and again? Any reason? So from that data, like most of the time, we need some requirement from the client side. We require some data from the survey data. So to design our solar system. Again and again joining and yeah, display. So first of all, load analysis. Like for the hybrid system, when we are designing our hybrid system, we need the load, peak, daily, and proper load profile of that system, or an off-grid system. We need the load profile of that house to design our systems on that basis. What is the load? Like uh, we have 2 kilowatt system load, and 1 kilowatt is running from that hours, one is from that hours. Like we have different appliances and they have different loads available. And we will analyze, like if we talk about the local appliances like the fridge, the lights, the oven, the other things, and we will analyze that the fridge is running for the 24 hours, the lights is available running for the 8 hours, like other thing. And on that basis we will design our best systems, and we on that basis we will design our standalone systems. And also uh, total load is very important to analyze our on-grid system, that how much load they have, like the 2 kilowatt, 3 kilowatt, they have the load. On that basis we will analyze that how much unit they will consume in the month or in the year. And on that basis we will analyze that if our solar system like generate 1 kilowatt will generate 3 to 4 kilowatt hours in 1 hour, how much they will generate for the whole years. So that is why we require the load calculations. And the other is the survey data, like we will analyze that how much is the side azimuth, how much the side tilt angle, that any shadow is available on that side where we are installing our solar power plant. Side location coordinate, we need the side location or coordinate we require for the simulation purpose in the PVsyst, and also we have to make on the layout in the SketchUp to analyze the proper shading of that side. We require the site coordinate systems. Then most of the client, when we are doing the survey and we meet with the client, they require like the off-grid system, they require the hybrid system, the on-grid system. They give us the requirement that how what type of solar system they require that. So as a design engineer, we need this data from the client side. Like the site coordinate, we need from the survey data when we are doing our survey. And the side survey, tilt angle, azimuth, shading analysis, shading, it will be from the survey data. When we are personally doing the survey of that side, or someone from your company or from your colleague will do the survey of that side. The load analysis we need from the client side, like, and available installation space. This also get from when we do the survey data, survey of that site, or when the client has provided that data, survey data. They will provide that how much space they have. Like we have 145 by 83 feet area available, and they have no shadow object available in that area. So you have to just install our simple structure there. So, like foreign client available, and we are doing the installation, designing for that client. They will give you the proper survey data, like the systems requirement, site coordinate, the tilt angle, azimuth, the location of that site, the load analysis, and the space available, and solar resource data like irradiance, temperature, dust, wind load, soiling factors. These also will be get from the client side. They will give us the proper irradiance, temperature, dust, wind load, soiling factors. They will give us that, and also the soiling factor is very like important factor, but unfortunately we don't have any proper calculation of that, as per my experience. Someone from this class has experienced that. We have like talked to one company, like they are have one software available, online software, PV radar. They are doing the soiling factor calculation, but at that time we don't have any proper soiling factor calculation. We just assume that we do the through the Excel calculations, the rain available in that area, wind load and dust, temperature, radius. They will give us the TMV file, uh, TMV file in the solar GIS data and meteornom data, uh, the weather file. They in which they will give us that the global horizontal radius are that, the direct normal radius are that, in like they provide that data the client side. And component selection. System component selection is very important. Like what is the PV module? What is the inverter? What is the power of that PV module? Basically, it will be selected on the basis of the inventory available in your company. Uh, the updated are like say that uh, the latest
Hello, sorry
technology.
for disturbance.
Yes, yes.
Sorry for, but someone again and again removing us, like me, Ahmed. Why someone is creating mess in this webinar?
Yes, I have just like Rahmatullah
Yeah.
again and again. I think they're losing
What is
like
the problem
somehow.
with one who is creating mess, disturbing in this webinar?
Yeah,
So
yeah, me
so
also.
kindly, yes, kindly coordinate, cooperate with us, because
Please,
you know that
respect.
it will
Don't do this.
create the distraction in the class. So kindly,
I'm
uh,
requesting all of you again.
okay, Mrs. F. Okay, the selection is very important. Like the PV module, the inverter, the MV stations, and other things. And also the grid compliance with the standard and the grid codes. For the large scale project, when like 100 megawatt, 200 megawatt, when we are connecting our solar system to the grid of that existing company, like that, like in the Tanzania, the TANESCO, in the South Africans, in the ESCOMs, So we have to follow that standards. What is the KVR requirement of that system, that grid? What is the requirement of the active power of that grid? We have to follow that standard. What is the minimum and maximum variation in the voltage? What is the variation in the power factors? So we have to follow that standards and comply with that standard, and we have to give them the we have seen that most of the client will give when they give us the data, they will clearly mention that your system will give them the grid limitations. Grid limitations mean that they give us that 100 megawatt power, active power will be available for the grid at any time. When your voltage up and down, like the 10% change in the voltage, your active power will not change. Like we have one solar power plant we have installed in South Africa. It is basically now in the commissioning phase, 283 megawatt system. And we have the limitation of the 240 megawatt grid limitations. We have to provide the 240 megawatt AC power when the the change in the voltage from the 10% down and 10% up. But our active power will not change in that variation period. So we have to meet the VAR requirement of that grid on that voltage changes basis. So it is called the grid compliance. It is a complex study. Mostly international company will do that compliance study with the grid code. They will done in the Power Factory software. And then we move on to the PV module selections. Basically, when we are doing the selection of the PV modules, they have the different type, the monocrystalline, polycrystalline, bifacial, monofacial. Now, in that era, polycrystalline is like demolished, depleted. Monocrystalline system is available. Monocrystalline PV modules are available in the market now, these era. And also the monofacial is going in the Bijan area. The bifacial PV module is the preferable systems, because they will generate the power from the back side of that PV module also, and they will generate more energy through that PV modules. But the drawback is that when we are installing our solar power plant on the tilted rooftop, and we have to follow the same slope of that buildings, they will not generate the power from the backside, because they will be insulated and they will be covered with the sheet of that rooftop. So here we have to install the monofacial PV modules. Then the efficiency and capacity consideration from the client side. Mostly the client will give us that how much efficiency of the PV module is required. What is the capacity requirement? They will give us that like the window. Like they will tell us that the 555 watt to 700 watt, you should select any PV module in that window. And efficiency, they will give us the efficiency bifaciality ratio. They mostly client will give us that requirements. Tilt angle placement planning, it will be decided by the EPC side. Design team will decide that how much energy they will get, more energy, more form of the tilt angle, and the placement planning. But the structural things will be done through the client side. The client side will decide that which type of structure they will require, like the fixed tilt structure they require, the tracker system they require. And then the manufacturer, mostly the client will give us that the list of the manufacturer, like the Trina, the Jinko, the Canadian. They will give us the some 4 to 6 number client manufacturer list, and we have to select
Hello, sir.
that. Yes.
Sorry to disturb. I have a doubt.
Sorry,
So I have a doubt. Can I say that? Sorry to disturb.
what type of doubt? You can ask me, no issue.
Okay, thanks, sir. So while considering monocrystalline type panels, there is actually two sides. Okay. On the peak time, we can expect maximum performance from the one side. It is the top side. And in the rear
Okay.
back side, what is the actual we have to consider? It is a radiance or the sunlight. It's actually performing in the back side of the panel on monocrystalline. Sorry, bifacial monocrystalline.
Yes, but yes. But in the bifacial, basically, when we are doing the installing our solar power plant, solar system, when the global horizontal radius strike on the front side of the back structure, and some rays will strike back, and we have to like give the pitch area in as minimum as possible, that these rays will strike to the back of the front structures. I will show you in the next part how they will strike that, and that rays will generate the power from the backside. So it is mostly that like that 10 to 15% of the total the nameplate of that power. Like we have the 680-watt PV modules, and from the backside it will be generating like the 10 to 15% power.
Okay, sir. Can you clarify which is sunlight or the actual radiation, the temperature? What is the
No,
actual
no, no.
concern?
Basically, when the global horizontal radius from the sun will strike on that PV modules, it will like give them the energy to the valence electrons, and they will travel in the form of the electrons, and they will generate the power, not the temperature one. Basically, temperature is uh, through the heat, in the form of heat, but electricity will be generated through the irradiance which are striking on the cells of the PV modules.
Okay, sir. Thank you.
Okay. So they give us the manufacturer list and also the degradation rate. The degradation rate, mostly the manufacturer will give us that how much the degradation rate is available for the power PV modules. For the first year, they will give us the like the 1%, and from the second to 30 year, they will give us that they have the annually degradation 0.4%, 0.45%. They give us and then the warranty and certification from the PV module supplier. And then the other part is PV modules basically generate the power in the form of the DC energy, travel through the wires, the DC wires, and then they combine on the inverters. Inverter will convert these power to the AC. So they have the two types. One is the string inverter, and the other is the central inverter. Basically, the string inverter in the low capacity, like the 200 kilowatt, 300 kilowatt. Central inverter is the higher capacity, like 100 megawatt. Sorry, the 1 megawatt, 2 megawatt. String inverter has the more number of MPPT trackers. Central inverter has less number of MPPT trackers. So string has less string mismatch losses. Central has more string mismatch losses because they have only one MPPT, and when there are the much difference between the higher voltage drop and lower voltage drop on the cables, it will generate the mismatch losses. So there are some uh, difference in the central in the form of string inverters. Uh, Sizing based on the load and panel capacity. We have to size our panel inverters on the basis of the panel capacity, panels, PV module, the current, and inverter input current. Then MPPT input and efficiency. The the manufacturer will give us that how much MPPT tracker are installed in our one inverter, and how many number of strings will be connected to the one MPPT trackers, and efficiency also given by the manufacturer. Q and night. Q and night is very important in the large scale project. When the system is like the solar system is cut out, but we have to provide the VAR compensation in the night times, our systems. So our inverter will generate the VARs. It can generate the VARs. Basically, now the large scale inverters like the string and central inverter, they have the capacity of the VAR kVr generations. So nighttime when your grid is off, and we have to provide when the grid is on, we have to provide the kVr productions from the inverters. They some the string inverter will not generate that power, but the central inverter has a Q and night functionality. Then manufacturer will be given by the client side. Then maximum cable terminations given by the client's manufacturer side, how much AC cable maximum size will be terminated on that systems. And then the protection of the DC, like the fuses and the breaker sizes. And then software workflow, like the AutoCAD rooftop modeling simulation. This one is for the just and simple project flow. How we will do some projects designing. Like first of all, it will be conducted the site survey when a client or any person want that I have to install our solar system. They will first invite some companies to visit the site, analyze the site conditions, the rooftop condition, ground mounted conditions. On that basis, they will request the companies and to give get the quotation from the companies. They will design and simulate our solar systems. Then after client approval, they will material procurement, and then the system installation, and then system is installed, the testing and commissioning work is. And then one is that design and simulations means that design approval, proper design approval. After that, when first is the bidding design, when the client has requested the companies to do the design, they will give them bidding design and bid for the getting of that project. When they get the project, like the client has given the approval and give them the price percentage of that project, they will again design the solar systems and get the approvals from that client properly. And after that approval, material procurement, and then system installation, then testing and commissioning. And after the project is done, properly designed, installed, there are might be some changes in the design drawings. Like we have do the drawings for the layout, PVsyst and other things. And there are some changes as per the actual site installation. Again, we have to change that drawings in the form of as-built drawing work, and we have to submit the client for the future O&M purpose. And then mistakes to avoid, like the oversizing, undersizing the systems, ignoring the shading and the orientations. Like we have oversizing, undersizing mean that we when we are doing the cable sizing, most of the times people do the oversized cables or undersize the cable. They are both the mistakes. We have to optimize that design. Ignoring the shading and orientation means that any object is available which cause the shadow on our solar power plants. We have to ignore that area, and we have to left that space for the shading purpose. Improper cable sizing, protection design, proper cable sizing protection design is very important. When we are not doing that properly, it will cause in the form of life of the humans which are working on that area, and in the form of the money drawback. Improper cable length, when we are calculating the length, the voltage drop, we are not properly do that, it will cause it will cause uh, the more uh, cable losses in the form of the power, and it will decrease the performance and the energy number of the solar systems. Wrong equipment coordinations, like uh, we have not properly designed the system. They have no coordination in between, like the inverter and MV station coordination and other things, like the other equipment coordination is not properly designed. They will cause much impact in the futures. Then in the next part, we will do the 100 kilowatt layout formation data. Coordinates are available that I have just collected from any side. The length, width, this, and the name of that cold storage area. L2 type structure we have to install 18-degree tilt angle, and we will give them, we will make a layout on the SketchUp, then convert into the form of the simulation report, and then we will convert into the form of the AutoCAD file, and we will make a short, small layout of that system. Hopefully, I will explain the things now. We are doing like the 15-minute breaks, uh, and we will again join that session after 15 minutes. Like it's time 10:40 in Pakistan. We will join again 10:55. Okay, okay, guys.
Okay.
Okay, for the 15 minutes. Okay, for the 15 minute. After that 15 minute, we will like again join that class.
Okay, thank you.
Okay, thank you.